Hello, everybody. Hello and welcome. Welcome to Science on Tap. Thanks for coming. My name is Carol Warden. I work at UW Trout Lake Station. Before we get started tonight, I have a message from our sponsor and partner, WXPR Radio. They couldn't be here tonight because Phoebe got the flu. She's the representative from there, so I'm delivering for her. She wants me to remind you all that WXPR brings local news, storytelling, music, podcasts, such as All Things Outdoors, The Stream, Field Notes, and much more. Listener support enables sponsorship of important community events, such as Science on Tap. But to keep this work going, they need your help. So WXPR's Spring Member Drive begins tomorrow, and never before has WXPR been more valuable or more vulnerable. Right now, public media is facing an unprecedented threat. They have reports of a memo drafted to rescind all federal funding to media funding, funds that make up a significant portion of the rural station budgets, and specifically 25% of WXPR's annual budget. So this is a critical moment, and if you value WXPR, independent media, please consider donating to WXPR.org, and thank you for being part of that community and standing with WXPR. So back to Science on Tap. Science on Tap is an example of the Wisconsin idea, an idea that the borders of the university are the borders of the state. And our partners in Science on Tap are Rocky Reef Brewing. Thank you very much for hosting us. We also have the Lakeland chapter of the Wisconsin Alumni Association, UW Kemp Natural Resources Station, UW Trout Lake Station, Minocqua Public Library, and WXPR Radio. And Science on Tap is supported by the Brittingham Fund through University of Wisconsin-Madison. There's 3 ways to watch, joining us right here in person. Thank you for coming out. You can also watch on YouTube Live. And when you watch on YouTube, you can ask questions in the comment box and we can relay them here in person. And there's also a link for that on our scienceontap.org website. You can also watch these events later. So we archive all of them, put them on our website, and you can go back and view them at any time. Our next event isn't until next fall, so we take the summer to concentrate on our lake research, as you can imagine. So we'll be back here in October, right here at Rocky Reef. Same bat time, same bat station. All right, tonight we have Dr. Tracy Holloway of UW-Madison Nelson Institute. Dr. Tracy Holloway has been a professor at the University of Wisconsin-Madison for over 20 years, appointed in the Nelson Institute for Environmental Studies and the Department of Atmospheric and Oceanic Sciences. She serves on the Air Management Advisory Group of the Wisconsin DNR, and she is the 2-time lead of the NASA Health and Air Quality Applied Science team. At the University of Wisconsin-Madison, Professor Holloway works with a team of scientific staff, graduate students, and undergrads on projects supported by NASA, NIH, EPA, nonprofits, for-profit companies, and generous private donations. And per tradition, we have a story about Tracy. She grew up in the suburbs of Chicago. Don't hold that against her. Where the Northwoods of Wisconsin was a regular family vacation spot. In her last year of her PhD at Princeton University, Tracy saw that the University of Wisconsin was hiring assistant professors in energy systems and policy. At the time, she was not yet in the job market, but when she saw the opportunity to live in Wisconsin, it sounded like a dream come true. As she said earlier, it was like getting a job at Disneyland. She applied to the position in the spring of 2000 and had her first interview that fall. Then she didn't hear anything back for over a year and assumed she didn't get the job, and she moved from Princeton to New York City to work at Columbia University in September of 2001, where her first day of work was actually on 9/11. Nearly 6 months later, she was contacted by UW-Madison and invited for a second interview, and she got the job. And she's been a happy Badger ever since. So now she's living the Wisconsin dream. So, what Northwoods town won her over and made her pursue a career in Wisconsin? Sorry. A, Bayfield. B, Butternut. Or C, Boulder Junction? Bayfield, Butternut, or Boulder Junction? Ooh, I got a few responses. Boulder Junction it is.
Yeah.
All right, now Tracy Holloway.
Oh, well, thank you, everyone, for coming out tonight. And it is just such a pleasure to be here up in Minocqua. And thank you, Carol, for that lovely introduction. I'll be talking this evening about air quality. And when we think about air quality, I think a good place to start is to think about how air quality probably isn't something you think about very often. Carol was just telling me about a trip that she took 2 weeks ago to Kenya. And in Nairobi, the air was so hazy that they couldn't see a huge mountain that was in the distance, but just obscured by the air pollution. And this is a pretty typical experience. If you go to countries around the world or look at National Geographic, or if you look at old movies like Rocky in the United States, the air is filled with haze in most urban areas and many non-urban areas. In many parts of India, the air pollution is even worse outside of cities than it is in the cities. But here in the United States, we don't have that problem. We look out the window and the sky is clear. And it's clear almost everywhere, and it's clear almost every day. And so the question is, how did we get such clear air when we use more energy, drive more cars, have a bigger population, a growing economy? How is it that our air is so clean, given all we do? And the real answer is the 1970 Clean Air Act. And my work at the University of Wisconsin is really trying to think about how to bring the best available science to bear on this huge issue of air pollution control that we've been working on since 1970, and our air continues to get cleaner and cleaner and cleaner. So this is a good news story. Often in environmental work, you hear about bad news stories, but for the most part, air quality is a success. And it's a success because we have invested and advanced technologies and been making the change. So I think a good place to start with this is, first of all, not only am I a big fan of the North Woods, but I'm also an optimist and a middle child. I like to walk the middle line, and I do work with a lot of nonprofits. I also do work with for-profit companies, energy companies. When I teach classes at UW-Madison, I like to have folks coming who can represent perspectives like the paper mills, and also come represent perspectives like kids with asthma. So one of the things about air quality is it really cuts across much of our economy, our energy system, rules going back decades, yet it remains a big part of our environmental management system. So before we talk too much about air quality, I'll just kind of lay out the atmospheric policy world as I see it. If I had a PowerPoint behind me, which I'm really glad I don't, but it's a little unusual, that I would say there's really three big buckets of what we think of when we think about chemicals in the air. And there's the chemicals in the air that we think about with climate change, chemicals that warm the planet. And carbon dioxide is number one in that group. And I'm happy to talk about that, but that's not really what I mean when I say air quality. Then there are the chemicals in the air that float all the way down to Antarctica and eat up the ozone hole in Antarctica and are under control. And in fact, the ozone hole is recovering. And I'm happy to talk about that too. But that's not what I mean when I talk about air quality. When I think air quality, it's really chemicals in the air that make people sick, that impact crop yields, that impact visibility, kind of anything that's not climate change or the ozone hole. But we can talk about any of those if you want during the Q&A. And of all these chemicals that have different effects, the backbone of the Clean Air Act is really structured around just 6 different chemicals. And I won't list them all, but I will mention the top two. There's really public enemy number one and public enemy number two. And public enemy number one are called fine particulate matter. And these can be liquid or solid, suspended in the air. We can't see them. But they impact our health. They shorten life expectancy. They irritate our eyes. They lead to more heart attacks. There's a lot of negative outcomes for fine particles. That's public enemy number one. And public enemy number two is ground level ozone. Now, ozone is one of these chemicals you've said, well, didn't you just talk about it over Antarctica? And ozone is a gas that is naturally occurring way up high in the atmosphere. And sometimes we say good up high, bad nearby, because way up high, ozone acts like a naturally occurring layer of sunblock. But just like you don't want to drink your sunblock, we don't want to breathe the ozone near the surface. So PM2.5 and ozone, these are the two big chemicals that really are driving much of the action around air quality. And one of the reasons why they are a little tricky to control is because they're not emitted from tailpipes or smokestacks for the most part. Instead, there are ingredients, chemicals, that cook up in the atmosphere to form these two problems. So in controlling ozone, we're actually controlling its ingredients. And in controlling PM2.5, for the most part, we're controlling its ingredients. And just by way of example, when you burn coal, it can emit sulfur dioxide. And that sulfur dioxide is a problem itself. But the main reason we control sulfur dioxide in the United States today is because it cooks up to form public enemy number one. So when we think about this pathway of clean air control, I want to say a few kind of bullets that I feel like resonate why I think it's an important thing, why I've devoted my life to it. One is that in the United States, we do spend a lot of money to have that clean air out the window. And a White House study that came out a few years ago identified the cost of all federal regulations. And about 70% of all non-funded federal regulations were environmental controls. So environmental controls are very expensive. And within environmental controls, about 70% of the cost is air. More than water, more than land. And so that's about half of the money that we're spending on federal regulations is on air quality. So we are spending a lot of money. But the good news is that for every dollar we spend to make cars cleaner or industries cleaner, we're getting about $30 worth of benefits. And depending on how you run the numbers, it can be much greater. And the main reason that we get benefits is because we live longer. In America, we're willing to pay a lot of money to live longer lives, and study after study after study has shown that having less air pollution in the air means the life expectancy is going up. In fact, you can parse apart the role of improved healthcare or diagnostics or diet, and the role of cleaner air is a big reason why Americans are living longer. So in the United States, our air has been getting cleaner for almost all of the pollutants that are regulated since 1970. That is not true around the world. Many countries' air is getting dirtier and dirtier and dirtier. Our air is getting cleaner, not because we're not using those fuels, but because we have add-on air pollution controls. So when you drive your car, it probably has a catalytic converter. The catalytic converter is a device specifically made to pull out these ingredients of these top two air pollutants. And it was invented a while ago, but it really didn't catch on until after the 1970 Clean Air Act. And now the catalytic converter is in every internal combustion engine. You may have even heard that they're getting stolen for their for their metals. But this is an example of why we can still drive a car powered by gasoline. It's just cleaner because of technology. So a lot of the work that I'm doing is trying to think about how can we make science help this very expensive, very impactful, and very beneficial set of rules that have been on the books. And one of the big roles that I have put time into is leading the national team for NASA, because there's satellites up in space that can see chemicals in the air that we can't see with our eyes. And those data are freely available on the internet, and they've been orbiting the Earth for decades. And so often I'm at meetings, maybe like this, where I feel like I'm a salesperson, and I am literally trying to convince the audience of the value of this billions of dollars of data that are totally free, ready to use. You just go to the internet. And but that's not as easy as it might seem, because again, the Clean Air Act has been around since 1970. It's very litigious. It's very structured, and satellite data play no role in it whatsoever. So it's really this question of like, well, we could benefit from satellite data, but how exactly? And let me just tell you one example of how satellite data can help the Clean Air Act, the clean air process. Here we are in Oneida County. There is no air pollution monitor anywhere in the county. There is a monitor right over in Vilas, but that's one of the few in this area. In fact, of the 72 counties in Wisconsin, only 29 have monitors. And most of them don't have both monitors, just one or the other of those top two pollutants. Most states have huge areas with no monitors. Even big cities might have monitors only in certain neighborhoods. We have no monitors over any water body, and many countries have no monitors at all. And so if you're thinking about understanding what's in the air, and is it going up or is it going down? Where is it higher? Where is it lower? Satellites can provide information every day around the world, again, for free, because it's already up there in space. And in late 2023, the US launched the first satellite over North America that could detect many of these air pollutants on an hourly basis. This satellite is called the TEMPO satellite. And even though the data started flowing in 2023, the scientists were doing a lot to correct it and check it. And so it actually wasn't available to use until just 3 months ago. So this is really new. And so one of the things we're working on with our NASA team is to say, how can we take this amazing new satellite and use it to be filling in the gaps and to be helping move the policy and the science forward. So I am happy to talk about any topic related to air quality or energy or related things. And but I think I'd love to open it up to make sure that we're talking about whatever you're most interested in. Thanks.
Mary will be going around with the microphones, so if you have a question, please raise your hand and wait for her to come to you. We have an online audience also, and the only way they can hear us in this room is through that microphone, and then all of us can hear you too. So raise your hand if you have a question, and she'll come to you.
I'm a rookie, so. Anybody question?
Can you touch on what these wildfires out west and last year out east do to our air quality here? It seems like it's really gotten bad at certain times of the year. We get beautiful sunsets from it.
Yeah.
But that's about it. Because it appears to be that it's a lot more than what we hear about.
Absolutely. Yeah. So maybe I'll say if I were giving a talk or teaching a class 3 years ago, 5 years ago, I would have said that the air pollution control story in the United States is a unilateral success story. And I almost said that, but I knew we were going to talk about the wildfires, because actually across most of the country, air pollution had been getting cleaner and cleaner and cleaner until 2023. And then it started going back up. Now that was across most of the US, but actually in parts of the West, it was 2017, it was 2018, there were really these unexpectedly big years. Oh, and then 2019 again, and 2020 again. And so there is a change with bigger, longer wildfires that are playing a much bigger role in our air. And so there's two ways we could look at that. I mean, maybe three. The first one is, why is this happening? How can we stop it? What's the cause? That's a huge topic, but that's sort of a land use topic, a long-term climate topic. I'm going to put that one to the side. A different one is, how is it affecting our health? And actually, it is not healthy to be breathing the smoke from the wildfires, just like it's not healthy to be breathing particles from a power plant. But luckily, those events are not throughout the year. They tend to occur mostly in the summer, and they tend to only affect an area when the wind is blowing right in that direction. The best strategy, if you know that that you're going to be affected, like going into this summer, there might be more smoky days. The best strategy is to have an indoor system that can filter your air. And that doesn't mean buying a fancy air filtration system. Actually, studies have shown that you can make your own air filter with paper HEPA filters, like from a furnace. And you just tape them together with duct tape and put a square fan, like one of the ones from the hardware store. And actually that performs almost as well filtering your indoor air as a lot of fancy air quality filters. It's called a Corsi Rosenthal box. And if you Google like DIY air filter or something, I'm sure you'll find how to do it. But duct tape filters and a fan can help protect your family and your indoor air when it is smoky. But a third way to think about these extreme wildfires is to think about, how do we think about air pollution control, and we're spending all this money to make our air cleaner, when we have the wildfire smoke coming in and that's outside of our control. And this is the way that the EPA handles this, or has handled it, is by calling these wildfire smoke events exceptional events. So for the most part, like if you take the monitor in Vilas County, if there are a couple days that are really high due to wildfires, then they erase those from the record, because they don't want they don't erase them from a health perspective, but they don't want to burden the industry in this area with having. It's not fair to say that it's the fault of industry when it's not the fault of industry. It's the fault of wildfire smoke blowing down. So they want to be able to say, like, is this pollution we can control, or is this pollution we can't control? And if we can't control it, well, we want to make sure that we are still like protecting people's health, but we don't want to be over-regulating around bad information. So this idea of, okay, this is an unusual event, it's not our fault, let's figure out why. This sounds like it should be easy, but it's not that easy, because air pollution does not come with an import-export label. So if you have a high air pollution event in Vilas County, how do you know if it came from Canada, or if it came from Green Bay, or if it came from Chicago? How do you know? And this is one way that satellite data can play a role, because oftentimes you can see plumes of air pollution going from one place to another. There are other ways of figuring it out, but historically these have been very few and far between. So that for each day that was due to an exceptional event, they might write a 70-page report and submit it to the EPA. But as we're getting more and more of these wildfires all across the country, it doesn't make sense to write a 70-page report for every single day. And so there's actually kind of right now this big overhaul of how we think about wildfires in the framework of the Clean Air Act, because we want to do something that still makes sure that we're not we're being careful about saying, is this a wildfire day or is this a local pollution day? We don't want to mix those up, but it just doesn't make sense to write a master's thesis for every single one. And so one of the projects that I'm working on at Wisconsin is working with a former air quality manager and developing a toolbox using Google that air quality managers from states across the United States can use to kind of quickly filter their data and figure out whether this was a wildfire day or a clear day. That was a really long answer to your question. They won't all be that long, but that was a huge question. And I think that actually like the wildfires are really, I'd say, like priority number one when we're really thinking about the big challenges facing science and air quality today.
I own some property in the Oneida County area. I have a lot of water area on my property. What significance does water do as far as tempering or improving or making worse your air quality?
Well, that's a great question. I think that first I'll answer trees, because trees are a little easier than water. Trees actually emit a lot of chemicals, excuse me, called volatile organic compounds. And in fact, when you walk through a forest and smell that nice pine smell, that's a volatile organic compound called alpha-pinene. And so back in the 80s, Ronald Reagan was once quoted as saying that trees make air pollution. And these VOCs from the trees, they are an ingredient for public enemy number 1 and number 2, but mostly when they're reacting with human-made chemicals. So the trees are part of the story. The water is part of the story in a more indirect way. I would say that the biggest impact of water bodies are very big ones, like Lake Michigan. Actually, some of the highest ozone in the United States forms right in the middle of Lake Michigan, because you have the ingredients from Gary, Indiana, and Chicago, and Milwaukee coming out over the lake, where they kind of can cook up in way over the water and then be exported. So actually some of the highest ozone in Wisconsin, and actually across the United States, is in Sheboygan, which just juts right out into Lake Michigan. On a smaller basis, though, there's no clear answer to give you, but I'll say that a colleague of mine has been interested in whether some of the same kind of VOCs that come off of trees might also come off of coastal waters and shallow waters. Because if you want to think about a VOC, it's anything that's kind of smelly. Not all VOCs are smelly, but if you think of a smelly chemical, it's usually a VOC. So if you buy no VOC paint, it's not as smelly as regular paint. And if you're at a coastal, like in an area near a pond, you do sometimes smell certain smells. And I think this question is, what are those chemicals doing? Are they of importance in any way? So I think it's an interesting question, but I wouldn't say there's a clear answer. Yeah, thank you.
We have an online question. What effect does diesel exhaust fluid on trucks have, and does it improve air quality?
So diesel exhaust, I'll say I'm not, I don't know a lot about engines per se, so I don't know exactly what the fluid itself does, but I will say diesel exhaust is a big part of the budget of most cities in terms of the big part of the air pollution budget. So one chemical that's an ingredient is called nitrogen oxides. And in your typical city, the number one source of nitrogen oxides are cars and trucks. And even though you have about 10 times as many cars on the road, you usually have about an equal amount of NOx from the trucks and the cars together, because each truck emits so much. so trucks play a big role, not just with NOx, they also emit different particles. You can imagine the smoke that sometimes comes off. And how to optimize the performance of those engines so that they get good mileage, but they also aren't emitting too much of the problematic chemicals into the air. This is actually a topic that I know engine makers are working on, and researchers are working on, and I don't know how diesel fluid affects it, except to say that it probably does affect it, and it is a big part of the conversation. Yeah.
I know that all that new satellite data is really new, but have you been learning anything really cool from it yet?
Well, yes, thank you. So where do I start? So one project that I've been working on is with the American Lung Association, where they put out a report every year that gives grades to every county in the United States. And these grades are based on the ground-based monitors. So they're the ones who would only give a grade to the 29 monitors in 29 counties in Wisconsin that have a monitor. But we've been working to analyze what would every county in America, what would their grade be if we could use satellite data? And it's been interesting to see where some of the dirtiest counties in America are right along the southern border of the United States with Mexico, and many of those counties don't have a monitor now. So we can see these patterns of these hot spots of air pollution across the United States that we might not have even known about without using the satellite data. And maybe I'll give one more story, and this wasn't from my work, but it was from the team I lead, where air quality around the world is a big issue for foreign companies, or for U.S. companies who want to have foreign offices, or if Americans are thinking about working abroad. Because air quality around the world is so different than it is in the United States, there's a high level of interest in what is the air pollution in one country or another. And so that's why up until recently, the State Department had air pollution monitors on many of their embassies, but one of my colleagues at NASA has worked with the State Department to get satellite data into that same information system so that Americans abroad or thinking about moving abroad could get more information on what's in the air, even if the local country didn't have very good information.
Anybody else? Have to be able to leap over the table. There you go.
Curious what the actuals detected by those air particle detectors. Are those something that could warn us of any of the geoengineering particles that they're prospectively putting in the air? If those would be fallout, are these something that we register on the in those detectors?
Yeah. So so one, I'm not aware of any geoengineering particles that are currently being injected into the atmosphere, because it is there's a lot of concerns around health and well-being. But satellites absolutely can detect particles in the atmosphere. And what they usually see is something called aerosol optical depth. They don't see the particles directly, but what the satellites measure is light that is being, usually from the sun, bouncing off the surface of the Earth, and then back up to the satellite. So on a clear day, you get most of that sun coming down, bouncing back, and it can see the full, the optical thickness is not very much. But if you have hazy air, and whether that's from volcanic explosions, or air pollution, or dust storms, or smoke, the satellite then sees that not as much of the sun is bouncing back to the satellite, and they detect that as high levels of aerosol. And newer sensors on these satellites are then able to estimate what is the size of the particles, what might be their chemical makeup. So having indicators, do we think that this is dust or do you think that this is human-made pollution? So this is just one of the, as an example of the satellites would absolutely be able to see that. Yeah.
We have another online question. What are the potential effects of cuts to NOAA and the EPA?
Yeah.
To be continued, right?
Yeah. I mean, I'll just say I did my graduate work in New Jersey, housed at a NOAA lab. It was called the NOAA Geophysical Fluid Dynamics Lab. And it's a really kind of nerdy sounding name. But what it did is it was the first laboratory in the world that was using computers to predict the weather. The whole computers were one of the big, I don't want to say invented, because a lot of people, like you could tie it to different places, but Albert Einstein was working at the Institute for Advanced Studies, and at the same time, there was another researcher who was one of the early developers of computers. And this was in the 1940s, 1950s, 1960s, and but back even in the 20s, there had been a scientist who had this idea that if we had a way of calculating values, adding numbers together really, really fast, that we could predict the weather. And so his vision of how to predict the weather was to have a stadium full of people. We would all have pencils and papers, and I would write something and I'd pass it to you, and then you'd write something and pass it to me. And if we did this enough times, we could predict the weather. Now, it really did not work out very well with a big room full of people. But as soon as the computers started showing that, hey, we can do math really, really, really fast, then NOAA, even before it was NOAA, an effort of the US government said we should try to harness the power of these computers to give us better weather predictions. So this laboratory was started and based right next door to these early computers. And it developed the cutting edge technology on predicting weather, tracking hurricanes, estimating whether next year would be an El Nino year or a La Nina year. And so now that has been kind of a gem in the crown of NOAA, but just one of many, truly. And that's where I spent 6 years as a graduate student working in that computer modeling lab in New Jersey. And, you know, the people who are working there, they are amazing. Like, they are the top in the field. And they are really working just to make better hurricane forecasts. So, you know, I think we have an amazing science system in America. And it's, you know, I personally know a lot of the people who are being involved, impacted, and so I just hope that the science stays strong because it's been helping us as a country for a long time.
So how are kids doing in inner cities with asthma?
Well, you know, I think that the air pollution in inner cities is getting better for the most part. But one problem has been that these ground monitors that are tracking compliance with the Clean Air Act, they're not located in every neighborhood. They're not located in every school. And so one of the newer areas of research has been to say, well, we want to really understand how kids in one neighborhood may be affected differently than kids in a different neighborhood. And that's a social, maybe, lens on the question, but it's one that the science has really been able to plug into because there's been a big advance in low-cost air pollution monitors so that many cities can put out now monitors across different neighborhoods. And actually, like in Milwaukee, there's a network that is monitoring on all of the public schools or many of the public schools. and from a satellite perspective, actually now the satellite data are able to see at smaller and smaller resolution, just like a better and better digital camera. And so the satellite data can also start to see what's happening neighborhood to neighborhood, and informing how poorer neighborhoods or historically underrepresented neighborhoods may be affected in different ways. And so I would say this line of research has really been booming over the last 4 or 5 years. And there's been some big studies that have come out to identify where are areas at risk, and maybe are there some areas where maybe the story isn't as optimistic as as we thought it was. But on the executive orders that have come out over the last couple of months, it's been very clear that work on this field of environmental justice is not a priority of the federal government anymore. And so, it'll be interesting to see how that kind of thread of science that was just getting started, how that moves forward and if it bounces back. And, I'll just say personally, I had not worked in this area of environmental justice until about 3 or 4 years ago, when there was a big push to do more. And if there's a push, then you do more. And so we started doing more. And but just recently, there's been a lot of grants that maybe were written last year and now not eligible for funding under this year and this kind of thing. So, it's a little confusing as a scientist to try to navigate the politics when really we're just trying to figure out what are the questions that we can help out and answer.
I think about your comment earlier on in the talk about how a lot of our improvements can be attributed to the Clean Air Act. And I think about how it's easy for us to, I guess, have amnesia about that something went into place to improve things, instead of thinking, well, it's been this way. It's okay. It's fine. It's good. And I'm wondering your thoughts on, if the Clean Air Act or portions of it were repealed and we didn't do those things anymore, if we would inevitably get worse, or if we are in a new state of clean, or if we really need to push to keep all those things in place if we want to keep being healthy with clean air.
Yeah, I see your question, Carol, and I think the answer is some of the changes that we've made are in place. I mean, if the cars that we're driving are not all of a sudden going to become dirty cars tomorrow. On the other hand, as cars age, for example, some of their pollution control devices degrade. And this is why, has anybody here ever had to take a car to be emissions tested? A few hands go up? Yeah. Well, you probably did that when you were not living up in the North Woods. If I've lived in New Jersey, Chicago, if you live in California, Milwaukee, these are places that you have to take your car to be emissions tested. And the reason you take your car to be emission tested is because the county is failing one of these levels for ozone, the good up high, bad nearby pollutant. And the testing is to make sure that older cars that are degrading don't degrade to the point that they're really emitting a lot. So I think there's this question of, well, if we stop requiring emissions tested, then some of the older vehicles will start emitting more. And some of the controls that like power plants and industries have on are not permanent fixtures, but they're controls that have to be run. And in running the controls, it costs something. So if they don't have to be run, then perhaps they wouldn't be run, and then there could be more pollution. So I guess I would just say that the Clean Air Act has been in place for a long time, and it's a very slow-moving system. It's not something that can be changed overnight. But it is something that can be changed. I mean, it's a set of rules and regulations that were passed by Congress and implemented under the executive branch. And I think that a lot of it is kind of in the weeds. I mean, a lot of people, we don't talk about fine particles, we don't talk about NOx that often. But I think that, that I would expect that if there is a rollback of some of those rules, then we will start seeing an increase in pollution levels across the U.S., and not just because of wildfires, but due to human-caused pollution too, which would be a change, a big change.
Oh, I have another online question. Do you consider pollen an air pollutant?
So I do not consider it a pollutant, but it's pollutant adjacent. How's that? And the reason, I mean, I'll tell you a few cool things about pollen that I think. One is that it is a particle in the air, so it would count as particulate matter, but they tend to be big particles. And so they don't count into the fine particulates that we're really talking about from an air pollution control perspective. But they actually are often a problem during the same conditions that can lead to other pollutants. So ozone is often highest on hot summer days, and it can be some hot summer days that lead to bad pollen as well. I know at least in the shoulder seasons of fall and spring. You can also have pollution on days when air is still and kind of building up in the air, and those can be some of the same weather conditions that lead to high pollen. So I think that there's connections between the two. They certainly both affect, I have pretty bad allergies, and so I'm very aware of the pollen season. And actually, one of the researchers on the NASA team I lead a couple years ago, his focus was on pollen and how can we use satellite data to better understand pollen trends and predictions. So it's in the same orbit, but it's certainly not regulated the way that other chemicals are.
Whoops. There we go. I have a question. Would you talk a little bit about Science Moms that I know you're involved with?
Oh, sure. Thanks. Yeah. So there's an organization that I'm involved with called Science Moms, and this was started in 2002 as an effort to make climate science more approachable by moms. And there's this question, well, why moms? And in many households, the moms are making purchasing decisions. Also, studies have shown that women tend to be more tuned in to changing their views based on scientific information. I didn't do that study, but that was the rationale. And also, though, that moms are looking into the future. We're making decisions today for the well-being of our kids 30 years from now. And so I was invited to be part of this group, and I'm a scientist, and I'm a mom, and at first I'd always felt like these were two very different parts of my own persona, that one of them I did at work, and then I came home and I start cooking dinner, and then I'm in mom zone. But the truth is, they have come together for me in an exciting way because it's helped me understand more about what I'm doing at work and contextualizing it. And actually, I have two kids, my son Peter, who's over here, who's 15, but also I have a little guy, Henry, who is in bed right now because he's 5. And when I think about the future, for decades we've been saying, well, what's going to happen in 2050? What's going to happen in 2100? And those always seemed so far away. But Henry is going to be 30 years old in 2050. And so suddenly 2050 doesn't seem that far away for me anymore. And I think just this idea that this sort of long-term projection and change feels a little different when you know that your own kids are going to be stepping through it, and it makes it a little more personal. And so that's one of the reasons that I've enjoyed being part of this group. It's a nonpartisan science outreach effort, and as a employee of the University of Wisconsin, I feel like anything that I can be doing to help be teaching and educating and informing is also, a good use of my time. So yeah, it's been fun.
We have one more, they say.
Oh, and there's one in the back too.
Oh.
Yeah.
Oh, my gosh. Here, hand it.
Thanks for coming tonight.
Oh, thank you.
Maybe it doesn't apply, but I'm just curious, what would you recommend for monitoring like our indoor air quality, like in our homes, as far as, we spend a lot of time in our homes, at least like a third of our life sleeping. Can you just maybe talk a little bit about that?
Sure. Yeah, indoor air monitoring technology has really advanced just like the lower cost outdoor monitoring. Most of us already have at least one monitor in our home, your carbon monoxide monitor, but that monitor doesn't start beeping until the concentrations get really high. And so I think the kind of newer generation of indoor air quality monitor is something that can detect levels that may not kill you, but are something you want to be aware of. And the most, depending on how much you want to spend or how much you like following the data, you can get these indoor air monitors that detect a lot of different constituents. Fine particulate matter is often sort of the first line of defense there. And, I think that it is, I don't have an indoor monitor in my own house, I'll just say. And I would probably put a filter in before I put a monitor. But I think it would be fun to have a monitor just to know if the filter is working, or to be able to also compare what's going on inside with public data for what's outside. Yeah.
Can you do one more?
Yeah.
Okay. Given power must come from somewhere, do EVs improve air quality?
Yeah, that's a great question. So electric vehicles do improve air quality unless all of the energy is coming from coal. Now, when I say all, because really nowhere is all of the energy coming from coal. We get electricity from a mix of coal and nuclear, natural gas, and renewables. And so electric vehicles improve air quality for two reasons, maybe three. First, cars are driving right where people are walking and living and breathing. Like, look out the window, we see lots of cars. But power plants are usually much, much further away. So point one is that even if they were using the same amount of fuel and emitting the exact same amount of air pollution, the cars are right in front of us and the power plants are far away. So just from a location perspective, it is cleaner to have it coming from electricity. Two is that, when we buy a car, this is not the most state-of-the-art engine that can possibly be created. It's something that we have to be able to afford and that can go under the hood. But if you run a power plant, these are extremely efficient machines. So you have a much higher level of efficiency in a power plant than you do in an individual vehicle. But the real reason why folks are enthusiastic about electric vehicles from an environmental perspective is that we can get electricity from almost anything. We can get it from the sun and the wind, we can get it from nuclear, and we can get it from any fuel, liquid, solid, or gas. But our cars are built to run only on liquid fuel. So we can only drive our cars on petroleum-based gasoline or diesel, depending on your engine, and or maybe biofuels, depending on your engine. So I think the idea with electric vehicles, though, is that it cracks open the energy system to be coming from any source. And this same thought process is also why there's enthusiasm about moving home heating toward electric heating and heat pumps, or moving the stove and oven in your kitchen to electric induction stoves versus natural gas stoves. Because as soon as we move to an electric, we can get the energy from anywhere. We're not harnessed to the specific infrastructure that we already have.
All right. Well, thank you very much, Dr. Tracy Holloway. Thank you to all of you who participated tonight and to our sponsors, the Lakeland chapter of the UW Alumni Association, Rocky Reef Brewing, UW Trout Lake Station, UW Kemp Natural Resources Station, WXPR Radio, and the Brittingham Fund. We hope to see you back here next fall, first Thursday in October, and you can stay informed via our email list. We can sign up here if you're not on it already, or you can visit us at scienceontapmanaqua.org. Have a good night.